Welcome to Chapter 12, Section 6, called Isosceles and Equilateral Triangles. This is for Integrated Math 1 or IM 1. So just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the gradebook when you click that button so that your teacher can see what you've been working on and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt, because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you, because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started before you get there. Okay, so we're going to go through and we're going to take a look at some isosceles triangle pieces here. There we go. So just to have the diagram over here. And again, always, always, always get that diagram on your paper so that you can kind of mark it up there. You can scoot over so that we can definitely see what's happening. So this goes with the isosceles triangle theorem. So we have 7 and 7. That means that they are congruent to each other. This is an isosceles triangle. So I know that the base angles, the angles across, will be equal. And I know it's not directly across. That's not what it means. It's kind of like the opposite angle. So S is going to be congruent to Q. Well, how does that help me as far as I want to know what Q equals? Well, we also know that the angles of a triangle add up to 180. We worked with that for quite a few weeks. So angle R plus angle S plus angle Q have to equal 180 degrees. And angle S and angle Q are the same thing. And angle R is 40 degrees. So I can go 40 degrees plus, instead of S and Q, I'm just going to label them X. So I have X plus X equals 180. So now I can just solve for X. I have 40 plus 2X equals 180. I'm going to subtract 40 from both sides, because I want to know, what's left over for my two angles at the bottom here. So 2x equals 140, so that's all that's left over for these. And since they have to be equal, it makes sense that we're going to be dividing by 2. So we're going to divide by 2 and we're going to get 70 degrees. So both of these, it doesn't matter which one they would ask for, both of them would have to be 70 degrees. Because that's all that's left over. 70 plus 70 plus 40 is 180. All right. We do have an equilateral triangle here, so we are using that just a little bit. So an equilateral triangle also means equiangular. So if all of the angles, oh, that did not come out very nicely and straight there. All the angles are the same. What in the heck? Because I'm writing a little sideways on my board here. Like this. All the angles are the same. So they're all congruent to each other. I still have 180 degrees to deal with. And what I want to do is just divide it up evenly into 3 pieces. So 180 divided by 3 is 60 degrees. So whenever you have an equiangular triangle or an equilateral triangle, no matter what, no matter how large or small it is, all of your angles will be 60 degrees. So that's just one of those little things. If you can remember that, then you don't have to do the calculation. But if you forget, equilateral, all the opposite angles will be the same. I have 3 of them. I have to divide it up into 3 equal pieces. All right. Same idea. All right, so we're going to go ahead and look at this one. Zoom in and okay. So now, let's scooch that back over just a little bit. Okay, so we have our angles here. We have some congruent marks. So this is an isosceles triangle, meaning that at least 2 sides are congruent. So I can go opposite angles are also congruent to each other. Well, I know what this one is. So that means that this guy, this angle K, is going to be the exact same thing. It's going to be 4x plus 19. Or I could say times 2, because I have 2 of them. So that's another way you could write it into your equations. So now it's asking me to find the measure angle for each one. Well, in order to know what the angle measure is for each one, I'm going to need to know what this variable is. I'm going to need to go solve for this variable and then plug it back in so that I can find each angle measure, because they don't actually care what x equals, but I need to know what x is to find the measure angle for each one. So I have 2x plus 52 plus 4x plus 19 plus another 4x plus 19. And this is where I could have, instead of writing 2 of these, I could have gone like this times 2, and then I wouldn't have had to do 2 of them, but then we would have had to distribute. So we would have ended up with the same thing anyway. All of these added together equal 180 degrees. Always, 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 it's a triangle. They're going to add it to 180 degrees. So now let's combine some like terms. We have 2 plus 4 plus 4, so that's 8, 9, 10. And then we have 52, 19, and 19. So let's see, we get 8, 9, it's 38. And then we get, if we add 38, we get 10, 5, 6, 9. So we get 90 equals 180. So I just combined all my like terms here, and that shortened it up quite a bit. So that definitely made it a lot smaller just by combining my like terms. So I'm going to subtract 90 from both sides, and I get 10x. 90 minus 90 cancels, and I have 90 left over because 180 minus 90 is 90. Divide by 10 on both sides. So 10 divided by 10 is 1. 90 divided by 10 is 9. All right, so I know what x equals. Remember, this is not one of my answers. I'm not going to type 9 into any one of these. But I need to know what x is to come back over here and say, okay, well, angle L is going to be 2 times 9 plus 52. So, and they did give us a calculator on this one, so I'm going to go ahead and go 9 times 2 times 9, saying it backwards, plus 52, so just being not doing all that in my head. And then down here, I'd have 4 times 9 plus 19, so I have 4 times 9 plus 19. Ooh, why isn't it typing? 4 times 9 plus 19 equals 55. This will also equal 55 because it's exactly the same. And I can come over here and test this out and say plus 55 plus 70. And ta-da, I get the 180. So as long as that works out correctly, we're fine there. So now we just need to make sure. So K is 55. L, that was the 70. And M, that was also the 55. So it's just kind of going around, making sure that we're applying that isosceles triangle theorem correctly so that we know what all three angles are. And then if we have all three angles of a triangle, they add up to 180 degrees. So a lot of the time when we're doing triangles, that's one of the properties we're going to end up using. All right, so we have use the given information to complete the proof. Let me grab a picture of this guy so I can draw on it. Okay. All right, so we're given this diagram here, and it says DE is congruent to DF, so DE, this side is congruent to DF. So I have an isosceles triangle. We're also given that DG, this dotted line, bisects angle EDF, EDF. So I'm going to have to define that word bisect. What does it actually mean for my diagram? So when it bisects something, and in this case it's bisecting an angle, it means it's cutting it in half. So if it's cutting in half, it means that these two pieces will be the same. It's two equal pieces. That's what half means. So I know that's what that means. I'm not given this information, but I'm given the fact that it bisects, which means I can come to this information. I can arrive there. So I have a side and an angle once I prove this. So this will be more than just two steps. I'm going to have to put it in the given, put in the given, define, then I have side and angle. I'm trying to prove that this angle E is congruent to angle F. So let's see. I don't think we actually get to use the isosceles triangle theorem because it's actually telling us that we're trying to prove that theorem. The angles opposite the two congruent sides of an isosceles triangle are congruent. So I don't think we actually get, I wonder if that's in the list. That'd be interesting if it was in the list, wouldn't it? I don't see isosceles triangle theorem in the list. So they took it away because that's what we're trying to prove. Because I was going to say, really right away I can just go, okay, they're opposites, you know, but I'm trying to prove why is this true. So I'm going to go back and prove that the two triangles are congruent to each other. And the reason we care if the two triangles are congruent to each other is once the two halves of that triangle, the big triangle, like these two pieces here, are congruent, corresponding parts of congruent triangles are congruent. So that's a big one. That helps us finish this problem. Because if I can show the corresponding parts are congruent, well, E is going to be corresponding to F if I'm looking at the halves of the triangle. And by halves, I mean, let me actually highlight it. I'm going to say, like, this is kind of half the big triangle. And then we're also going to have the other part, which is this guy here. Like this. So if I can prove that the pink triangle is congruent to the yellow triangle, then once they're congruent, their corresponding parts are also congruent. So it's one of those things, we practice this quite a bit in section 4. I believe we had 2 different proofs that went through and used corresponding parts of congruent triangles are congruent, which we shortened to be Cpctc. So we don't have to write out all of those fun words there. So I do see a shared side right here. So DG is shared between the pink and the yellow triangle. So that's going to be my third, or my other side here. Once I state that it's equal to itself using reflex property. Anything that's equal to itself, that's reflexive, right? We know that. DG is equal to DG. So SAS, SAS. So that's side, angle, side. That's one of my properties that I can use to show triangles are congruent. So I kind of have my plan of attack here. I'm going to go ahead and start working on this guy. So I'm going to send a proof, send a proof. I don't want to send the prove yet because we're not there. That'll be at the very end. And again, if this is like the idea of getting dressed, I can't do this. This is the very last thing I want to do in the whole proof. Not prove, but in the proof. So in these statements and reasons, I don't want to send this until the very last thing. That's where I'm ending. So now I'm going to define this word bisect, where we know it's, and I can't say angle D because that could be the two smaller ones, that could be the larger one. So I need to go angle EDG is congruent to angle FDG, like that. And the reason for that is I'm defining what this bisector is, and it's an angle bisector. So it's definition of angle bisector. There it is. Definition of angle bisector. Perfect. So now I've got my side. That was given. I just defined what angle bisector was, so I have my angle. Now I need to show that this shared side is shared. So I'm going to say segment DG is congruent to segment DG. So they're congruent to each other. That's reflexive. So now I have angle, side, angle. Sorry, I said that funny. Side, angle, side. And I can go ahead and say that the triangles are congruent. So triangle EDG, so I just went, I'm actually using the same format as up here because I made sure they were in corresponding order, is congruent to triangle FDG, and it's because of side, angle, side. So I'm going to scroll down here and go side, angle, side, validate. All right, I'm not done. This is my last step. Now I can say that angle E is congruent to angle F because corresponding parts of congruent triangles are congruent. And E is corresponding to F, and I can even see that in this diagram. E and F are the same, are the first letters in my statement here. So that means they're corresponding. D corresponds to D, G corresponds to G. So they're corresponding to each other in that order. So that's why the order matters so dang much. So we're going to go all the way to the bottom, and corresponding parts of congruent triangles are congruent. And you can click on these little eyes. This will explain, give you the words for it, you know, so that you can actually see that. All right, the proof is complete. We can click check. And I think, did I not click it? There we go. So yay, we finished that one.